Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Module 4, Inter-VLAN Routing. So we're going to be looking at VLAN communication operations, the ability to have one VLAN communicate with devices on a separate VLAN. We're going to be looking at the process of doing this through legacy, router on a stick, and using a layer 3 switch. And then we're going to end with troubleshooting. So the router operations actually takes place 3 ways: legacy, router on a stick, or layer 3 switching using SVIs. So legacy literally is going to be physical ports per VLAN. Let me grab my pen. So this is VLAN 1 number, this is the second VLAN. So you actually have 2, my drawing was kind of bad, but I mean, this interface is tied to this network here. This one is tied to this one. Sorry, my mouse kind of went all over the place. With legacy, if you have 2 VLANs, you're using 2 ports. If you have 3 VLANs, you're using 3 physical ports. Legacy is all about VLANs being mapped to separate physical ports. This is no longer implemented because, well, 1, router ports are expensive, and in a switched network, we can actually provide better resources. And the more common way of doing this is called router on a stick. You have a trunk interface, and on that trunk interface, you can have virtual interfaces. So we do this using 802.1q trunk. And how that works is, I don't like that we don't have a diagram, but we have a router, and we have a switch, and we have one connection between the router and the switch. Well, this cable is going to be configured as a trunk with virtual exit points at the router level. That way, devices should be able to come into the switch, processed on the router, and sent back down the trunk, and then forwarded out the appropriate VLAN. We can also do this via a layer 3 switch. Here we have SVIs, switch virtual interfaces, that will allow for data to go from one VLAN to another. Now keep in mind, VLANs are separate networks. So to go from one VLAN to another, that's going to be using routing function or a routed port. So layer 3 switches, you can turn the ports into routed ports. So there are some advantages for using layer 3 switches. This is the newer way of doing it. However, layer 3 switches are really expensive. They are faster, and we are limited to certain things, such as, well, brand of the equipment is going to be one of them. Meaning, if you get like a Netgear switch, that may not be able to be configured as a layer 3 switch, where main name brand switches that actually classify as layer 3 devices should be working just fine. Some other pros are we're not limited to one link because we have Ether channel, latency issues are removed, and realistically, if we're talking large WANs or large LAN, we already probably have layer 3 switches spread throughout the infrastructure, and that's going to be far better use than a layer 3 router. Again, layer 3 switches are more expensive, but in this environment, a switching environment, they can be faster. So legacy we don't talk a whole lot on because realistically it's not supported anymore. So here we have a router on a stick. Again, this is our trunk right here. If we have multiple switches, we have to have trunks between the switches. And these switches will be configured. This will be configured a trunk port, this will be a trunk port, this will be a trunk port, and on the router side we'll have it configured as a receiving trunk port. And we do that by doing subinterfaces. So we have a parent interface, and then we'll do .10 or .20. These are normally tied to whatever VLAN number they are. They don't have to be, but that's pretty common. Like, I'm actually surprised this is not .99. Because you'll notice .10, .20, that's because those are VLANs 10 and 20. You have to treat the parent interface like it has to be turned on. You don't need to worry about giving it an address because all of the sub-interfaces will be given the addresses. These allow exit points. So how do we do this? How do we set up VLANing? Well, first, on the switch, we create and name the VLANs. We create the management interface if we're not using VLAN 1. We have to configure access ports and trunking ports. I always suggest hard coding these. I don't like using the negotiated port types. That's just me. But I mean, there's pros and cons for using them, which I've discussed in other videos. How do we actually configure that? Here's an example. From the global configuration, type VLAN 10, that creates the interface. That creates the VLAN. We can name it, and then we actually can navigate to those interfaces by typing interface VLAN and the appropriate number. That will create our SVIs. From there, we need to actually put in which ports are tied to which VLAN. So here is a perfect example. This is going to be turning interface 18 into a VLAN port able to access VLAN 20. First thing we do is we set the switch port mode to access. From there, we say which switch port, which VLAN it can access. We do that via switch port access, VLAN 20. We turn it on, and that's it. That's how we can configure our access ports. If we want to configure our trunking ports, trunks are a lot easier. Switch port, navigate to the interface, switch port mode trunk, turn it on. That's it. However, on the switch side, trunking is pretty simple. On the router side, it's a little bit more steps. So, how do we set up our sub-interfaces? Well, you navigate to whatever physical interface that trunk is plugged into. From there, we will create sub-interfaces. We do that by typing interface, whatever the interface is, dot, whatever the VLAN is. From there, we'll have to set the appropriate encapsulation. We do encapsulation using .1q space whatever the VLAN number is. That way, that lets us know this is the exit point for that specific VLAN. Then you can give it its IP address and turn it on, and we are good to go. That provides our virtual gateways. Here's an example. We set a interface. Here we're looking at the parent interface, gig 001. The sub-interface will be the .10. That means we're probably going to be using that for VLAN 10. We could do description if we want, but we don't have to. Encapsulate .1q. We have to say what VLAN we're attached to. It's VLAN 10. We give it the IP address, and we turn it on. If the parent interface is turned off, turning on the child interfaces will not work. We have to make sure that our parent interface is turned on. And you'll notice here we have .20, here we have .99. Notice that again .99 because the VLAN is 99. So we try to keep the interfaces the same as our VLAN numbers, though they don't have to be. And here is the parent interface, gig 001. They just turn it on and they list a description. A common thing that I notice learners here is they create the sub-interfaces, they create the encapsulate, and they assign an IP addresses. They turn on the children interface, but they forget to turn on the parent interface. So make sure parent interface is turned on. From there, we can now try pinging between one VLAN and another. Because we're using router on a stick, the router should accept and actually include in their routing table directly connected networks. And those router on a stick, the separate VLANs, are directly connected networks. So how can we verify? We could be looking at show IP route, that shows a routing table, show IP interface brief, that can ensure all of our interfaces are up and functioning. Show interface trunk, though sometimes that's not the easiest one to show on a router because they're not technically being set as a trunk. That'd be showing on a switch. Nice thing is we have a packet tracer where we're going to be creating the VLANs, configuring the subinterfaces, and then testing using those show commands. We'll do another one, building the network, setting up the switches and trunks, and then configuring the appropriate protocols. So moving on, how do we do this on a layer 3 switch? Again, enterprise campuses, large networks use layer 3 switches. We can do this using switch virtual interfaces, SVIs, and essentially we do the same thing, except instead of having to go to a layer 3 router, we can add it to the switch and we can configure the SVIs. And what we do is we go to interface VLAN, type in the interface VLAN that we want, and then from there we can create routable VLANs. Here's an example. We have a layer 3 switch. We have two physical ports, gig 106, gig 1018, separate VLANs. So what we would do to configure this appropriately is, first of all, on the layer 3 switch, configure the VLANs, both VLAN 10, VLAN 20. We would create an SVI VLAN interface for both VLAN 10 and VLAN 20. We would assign the appropriate IP address and ensure that they are on. Again, the gateway address of the devices have to match the interface or the SVI on the switch. Next step is on gig 106, we would have to set up port access, switch port mode access, so that it's a access port. On gig 1018, we would do the same thing, assigning that to VLAN 20. From there, we would need to enable IP routing, and we do this very easily by, at the global configuration mode, we can issue IP routing command. And this will allow traffic to be exchanged between the VLANs. This allows the switch to actually process the different packets, looking at layer 3 information, and then forwarding it appropriately. If IP routing is not turned on, then this switch will act just a layer 2 switch, only looking at the MAC address and not allowing for inter-VLAN communication. So for inter-VLAN routing using that switch, it's way simpler to configure and makes it kind of nice. Less equipment, but again, the device itself is typically more expensive. If VLANs are to be reachable by other layer 3 devices, they must be advertised using some type of routing functionality. So with that said, turning on routing on a layer 3 switch, then we should be turning on a routed port so that the port can share routed information. And we do this by issuing the no switch port command. We can tell the switch that port gig 0024 is a layer 3 port by issuing no switch port. That forces it to be a routed port. Why would we want to do that? Well, what happens when we want to share routing information? It's a layer 3 device. Yes, it's a switch, but it's a layer 3 device. So to share routing information between that device and another layer 3 device, we could do that. Here we're setting up OSPF, so we're going to set this port right here as a routed port. Again, you navigate to it, you would issue the no switch port command. That turns that port into a routed port, and from there you're going to treat that port as a router. You can then configure OSPF so that it knows the networks, and it will use this routed port to send and receive routing updates. How do we do that? Again, configure the routed port using the no switch port command, enable routing, configure the routing protocol, verify routing is there, and then use ICMP. Nice thing is we do have a lab on configuring a layer 3 switch. So moving on, let's talk about troubleshooting. How do we actually go about verifying and troubleshooting inter-VLAN communication? Well, there's typically 4 main areas that troubleshooting takes place when we're dealing with inter-VLAN communication. First of all, missing VLANs. We need to be able to show the VLAN, possibly show VLAN brief, so that we can see what VLANs are there and what interfaces are attached to which VLANs. Keep in mind, it is extremely important. If you configure a VLAN and you configure ports to be in that VLAN and you delete the VLAN, those ports do not magically get put back into the default native VLAN. They are attached to an orphaned VLAN. So you need to understand that. So when you do a show interface and you may not see all the interfaces attached to certain VLANs, that could be because the interface was attached to a VLAN that was then later deleted. So verify interfaces are attached to the correct VLAN, and ensure that physical issues, for example, you plug PC1 into port 2 and you configured port 2 to be attached to the correct VLAN. That is one thing that I see quite often. People plug in cables and they didn't configure the correct port, but they plugged in the cable into one port and they configured a different port for that device's access. Moving on, switch port trunk issues. Look at the interfaces. Look at the show interface trunk. Ensure that the trunk is functioning. Ensure that the trunking protocol is there. We use 802.1q. That is not the only trunk port in existence. That's just the one that you learn about through the Cisco Academy, and that's one that's pretty commonly used. Access port issues. Again, you're looking at show interface switch ports, looking at the actual interfaces. You want to make sure that you assign the correct VLANs to the correct access port. If we are looking at inter-VLAN communication, we have to look at the layer 3 devices. Specifically, if we're looking at a layer 3 switch, looking at the SVIs, making sure they're turned on, make sure that the addresses are correct, make sure that the devices have the appropriate default gateway of the SVIs. If we're looking at routers, we have to make sure that we have the correct IPv4 information. We also have to make sure that we have the correct subinterfaces and that we are encapsulating the correct VLANs. So for example, here we have 3 VLANs, VLAN 10, 20, and 99. We have our subinterfaces, we have our trunk. We could be looking at the different interfaces to ensure what is there. If here we do a show interface FA06 switch port, we are in the access mode VLAN 10. I'm going to go back. And that should be appropriate. VLAN 10 is attached to on switch 1 F06. But you'll notice here it's inactive. When a VLAN is deleted, any ports associated with that VLAN become inactive. They remain associated with that VLAN, but it's inactive, meaning that VLAN is not present on that switch. We can verify that by doing the appropriate show VLAN commands. We could be looking at switch port trunk issues. We can do that by looking at show interface trunk. It will tell us the mode, the encapsulation, and the status. It will also let us know the native VLAN, and it will say what VLANs are allowed and active. We could be looking at switch port access port issues, and again that could be doing show interface the appropriate interface switch ports, and from there we could be looking at the access modes, the operational modes, things of that nature. Essentially here we could be doing show VLAN brief, show interface, show running config. All of those things will let us look at the interface to ensure they're attached to the correct VLAN. If we're dealing with layer 3 devices like a router, we would be looking at the interfaces. We want to make sure that one, they're using 802.1q, and that they're using the correct VLANs. Did we accidentally fat finger 10 to 100? That's actually one that happens pretty often. We do have a lab troubleshooting. We have a second lab troubleshooting. So we got plenty of practice throughout this module. That's it for this module. We do have a lab challenge and a lab implementation. So what did we learn? We learned how inter-VLAN communication occurs. Legacy, router on a stick, layer 3 switching. We looked at how to configure router on a stick and layer 3 switching. We looked at the importance of SVIs and them being configured as a default gateway, and we looked at troubleshooting. We looked at a few of the show commands that were there. And that's it for this module. Questions, concerns, please reach out. Thank you.